Good evening. I'm an educator from Kepler Educations, and this is the 12th video of the POTD series. So this is one of the series that is being provided from Kepler Educations as a part of the YouTube channel, YouTube lectures. Very soon we will start our official live classes at the Kepler Educations at the Kepler 22B website. So please be sure to check out the website. I have provided a link to the website many times before in my previous lecture. Today also in the end I will surely provide the video. The link to the Kepler Educations website. So please check it out. Our courses are extremely low cost and are very affordable among students. And if you wish to study them, if you wish to study with Kepler Educations, then please provide a comment saying that you want to study. Or you can also put a comment at the group chat of our website. There is a community group which is open to everyone. Now, before wasting any more time, let us dive into the problem. So today's problem is container with most water. So we are given an array of non-negative integers where each element, array of I, represents the height of the vertical line at the index I. Then find the maximum amount of water that can be contained between any two lines together with the x-axis. In the case of a single vertical line, it will not be able to hold water. Very well. So let us check the problem. Now, there are quite a few ways in which you can solve this problem. So I will start with a very simple way, and I will build my intuition from that very simple way. So let us suppose we are given this particular thing. So let me draw it separately. Yeah. So 2, 1, 8, 4, 6, 4, no, 8, then it was 6, 4, 6. Okay, sorry, this was 6, 4, 6, 5, 4, 5, 5. So most basic observation comes is that the most basic observation that comes is the fact that you have to move row by row, and you have to move vertical by vertical. Let us suppose 0, 1, 2, 3, 4, 5, 6, 7. Let us suppose you are at the 0th vertical. Or let us do it from backward. Okay, let us do it from forward. It doesn't matter. Let us suppose there is 0th vertical. Then you will see till where this 0, this particular line can store water. You see, it can store water till the second vertical, it can store water till third vertical, it can store water till fourth vertical, fifth vertical, sixth vertical, seventh vertical. On this side, it cannot store any more water. So for 0, you have to look from the right side. You have to look from the right side. Look from right side. The rightmost greater element or greater vertical. Very well. So how much water will the 0 store? 1, 2, 3, 4, 5, 6, 7. 7 into 2, 14. And let us come to the second one. For this thing, this is a height of 1. It can store water in its direction till 7. So how much water can store? 1, 2, 3, 4, 5, 6. 6 into 1 equals 6. However, you have to look on this side as well. You see, it can store water till here. This is 1. Just to 1 into 1, 1 equals 1. So total amount of water is 6 plus 1, 7. So total 7 amount of water, this particular vertical. So similarly, also look on leftmost greater element, or from the left find leftmost greater vertical. So this, let us say from, let's say for index I, the rightmost vertical is j, and from index I, the leftmost vertical is k. So effectively the entire location, so effectively the height of this particular thing is I. So height is area of I. And what is the height is area of I. The height is area of I. And what is the width? Let us say the width is from I, j, k. Therefore width j minus k. Not j minus k plus 1, because you are finding out these gaps. These gaps. If you have j minus k plus 1, it will give you the number of verticals. You do not need a number of verticals, you need a number of gaps. So j minus k. So area or capacity, this will be area of I multiplied by j minus k. I will not write a brute force code, but this is the idea of the brute force course. So look from, okay, for index I, belongs 0 to n minus 1. Look index of leftmost greater k. Look or find index of rightmost greater j. Answer will be max of answer comma error of I multiplied by j minus k, and at the end you will return answer. This will take a time complexity of O of n square and a space complexity of O of 1. Can you decrease the time complexity? Yes, you can decrease the time complexity. You will do a pre-computation. In a very first video of my POTD series, lecture number 1. There was a technique which was the rightmost smaller element. It was the technique of rightmost smaller element. That technique had found out for each and every element the rightmost smaller in order of 1. Sorry, in order of n. Very sorry, in order of n. You can apply the same technique. You can apply the same concept to find out the rightmost greater element. Instead of rightmost lesser element, you will find the rightmost greater element. So please make sure to watch that particular video. POTT series lecture 1. There it was, rightmost smaller. Use in order of n. Same technique. It was about 55 minutes video. So obviously, naturally, I cannot tell you the entire concept right now, because if I say the entire concept right now, 55 minutes, the video on length will exceed one and a half hours at least. So I cannot use the technique right now. So use the same technique to pre-compute the leftmost greater and the rightmost greater in two different iterations. Let's say leftmost of I gives leftmost greater of error of I, rightmost I gives rightmost greater of error of I. Then your code will simply become, your entire code in this situation will simply become, for I belongs to 0, n minus 1, height will be error of I, left will be leftmost I, right will be rightmost I. You will define a weight here. If left not equal to -1 ampersand, if you follow the algorithm, you will find out that I had initialized these things with -1, and right not equal to -1. Then what will you do? You will say simply weight equals right minus left. Else if left equals -1, weight equals, it will be right thing that counted, so that weight will be equal to n minus right. Else if right might become -1, weight will be left. There will be one among these conditions, and if that doesn't exist, then okay, you can consider it as 0 in here as well, because one of them will exist. But if it is the maximum element, yes, if it is the maximum element, so you have to keep this condition. If it is the maximum element, there will be nothing on left, nothing on right. For example, for this particular situation, for this particular guy, there is nothing on left, nothing on right. So basically, this weight is 0. So else, I know it doesn't really matter, but let me write it. Weight equals 0. Ans equals max of ns comma h into weight, and finally we'll return answer. You see, the pre-computations take O of 2n plus O of n. So you are getting O of 3n time, and space complexity is O of 2n. So this is the thing. Time complexity becomes O of 3n, space complexity becomes O of 2n. And this is the brute force. I will not call it a better, because it's simply a weak extension of Brute force, or you may call it to better. Brute force, or you may call it better. You may call it better. Now we will do the optimal solution. The optimal solution is based on these understandings. So what is the target? You have to increase the amount of water that is stored. You have to increase the amount of water that is stored. So you have two conditions. You have two conditions. Condition one, keep the height, increase the height as much as possible for verticals. And what's the other condition? The other condition is increase the width as much as possible for verticals. Let us start with condition 2 first. Let us start with condition 2. Keep width as large as possible. Therefore, let I equals 0 and j equals n minus 1, and that is you keep the width as maximum as possible. You keep the width this thing. This is the width first. Now you will try to increase the height. You will try and increase the height. You see, you get an answer here. The amount of water that can be stored here is undoubtedly this much. So what is the amount of water that is stored? This is the amount of water that is stored. This is surely the amount of water that is stored. Okay, sorry. This is surely the amount of water that is stored. So amount of water stored and your previous answer. You will obviously initialize answer as something very small, let us say 0. So this will be your answer. Now you are trying to increase the area. You've got the maximum width that is possible. Got the maximum width possible. Right. Therefore, there is no chance in order to take on with this algorithm, there is no chance of increasing the algorithm without decreasing the width. Therefore, no chance of further iterations without decreasing width, as your width is max right now. Therefore, you can either increment I or decrement j to decrease width. Now, which one will you prefer? Your I is, let's say let's say this, and your j is let's say this. So which one will you prefer? Will you try, if you increase I, here error of I is less than error of j. If you increment I, if I plus plus, then min height effectively decreases. You do not know what will happen after you move I. You do not know, and you don't even have to know. You see, you work upon the current situation right now. Basically, you try a greedy algorithm. You are working on the local condition that is present with you right now. The local condition is I and j are the two verticals. The minimum of I and j, minimum of error I comma error of j is your height. Now you will try to increase the minimum height. And the maximum height you will keep it constant. You will try to increase the minimum height. You will try I will write this once again. I will write this later. I will now write what you will try. Very important to understand. Try to increase the minimum height, hoping to get a maximum height or greater height. Keeping the already greater height j as constant. So what are you doing in this process? In this process, the the greater height is fixed, reducing chance of the greater height being decreased, removing the chance of the greater height being decreased. So it will be removing the chance of the greater height being decreased. So effectively what you are doing? Effectively you are doing is what? You are fixing the greater height and you are increasing the lower height until you get a height which is greater than the greater height. So increment I, you are increasing the smaller height. Increase the smaller height until you get a height greater than current greater height. So what are you doing in this process? You are finding the maximum. In this process, you are finding the maximum. For example, if it is this and if it is this, it is I, it is j. You are see, j is greater than all of them. J is greater than all of them. J is greater than all of them basically. J is greater than all of them. But this is greater than j. This is slightly greater than j. So if j is greater than all of them, if j is greater than all of them, so this I will move constantly throughout this place. But when I comes here, then j will start to move. Then j will start to move. So basically, you're finding a maximum. Then j will start to move until it comes here. And in this case, and in this place, you look carefully, and in this place, you will find the container with the greatest height. So what are you doing? So in this process of moving smaller height, keeping greater height fixed, this is most important. You are finding a height greater than current greater height. Now what happens in this situation? If new height I, error of I, is greater than current greater height, error of j. You see, in the beginning, what was area? In the beginning, it was error of I into error of j. Where, sorry, mean of, what was the height? It was min. You have to find out the min. It was the min of these two. So basically, it was this height only, error of I. Now, what is the thing right now? Is the I. So the current situation is min of, let's say this is error of I, this is error I, and this area is ANS1. This area is ANS1. The error of I, error of j. Basically, what is it? It is error of j. It is error of j. So this is the height. So ANS2. So effectively you see if it is h dash, if it is h2, and if it is h1, effectively what is happening? Since error of j was greater than error of I dash, therefore h2 is greater than h1. So in this process, what have you done? Therefore, in this process, you have successfully increased the height of water containing rectangle potentially increasing area of this rectangle. Why did I say potentially? Potentially only because width gets decreases as attempt of increasing height is done. So basically this is the entire algorithm. So what is the algorithm? The algorithm is that if left height is less than right height, left height will increase, else right height will decrease. No, right height will increase. Left height increases, therefore left index plus plus. Right height increases, therefore right index minus minus. Not necessarily, try, it will try. Increment tried and tried. Because you see, if the left height decreases, I mean if the height of the next container is less than the first container, that is, if this I dash, if I double dash is less than I dash, then simply this area will be even less. This area will be even less than ns1. So there is no significance of this area. There is no significance absolutely of this area. The maximum area will still remain to be error 1. It increases slightly, let's say. So there is a potential of height increases. Now it increases significantly. So this area ns2 might be maximum area, might. So this is the algorithm. So I will code up the algorithm right now. So first you will have two pointers. Int I equals 0, int j equals n minus 1, int ns equals 0. While I less than j, because there must be some width, and the maximum width, ensuring max width. While I less than j, what will be the height? Min of error of I, error of j. And what will be area? Answer equal to max answer comma height into j minus I. If error of I is less than error of j, if they are equals, then reduce any of them, doesn't matter, reduce any of them. I plus plus right left index increments, or try to increment right height, therefore right index decreases, and you will return answer. This is the overall algorithm. So you will try to increase the left index, you will try to decrease the right index. Basically what you're doing, you are trying to find out a height which is greater than the current left index, and you are trying to find out a height which is greater than the right index. Slowly and slowly. This way it will run. So before going into time and space complexity, let me show you the code. So first if you initialize answer with 0, then I equals 0, j is error to size minus 1. These to ensure the maximum width. Now as you're moving leftward, as you're moving this side, lower area, suddenly a greater height, possibility of a greater area, we are not sure. Possibility of, we find it out and see if it is greater or not. Then certainly a greater area. This area is definitely a greater area. No, not definitely. This height is definitely a greater height. This height is definitely a greater height. So take them into account. You're taking the height of rectangle. Now, this height is fixed. You will try to find a height greater than this height. Why? If you try to find height greater than this height, this is the maximum height that has been found till now. There might be another element that is greater than this, but this is the maximum height that has been found until now. So take this area. So whatever you take, you take this, let's say it is this, then this area will be done. But effectively, this full height will not be considered. Whatever height is considered less than this height. So if you have to count the full height of this particular area, take this area. Let's say the other one is left. Now you have to find out the full height of this particular area, like this particular vertical, full height of this particular vertical. Increment this line and see if it is greater or not. This is why the algorithm works. So why is I less than j? I need some width. So this is the height, mean of error of j. This is the width, j minus I. You're finding the area, current rectangle area, and you will taking the maximum value. of answer comma current rectangle area. If the area of current rectangle area is greater than the answer value, then obviously it is the greatest element area, that is the greatest internal water has been found till now, and so on. So if the height of I is less than height of j, that means the height of j has not been fully utilized. You have to find something whose height is greater than the height of j. I1, that is I plus 1, is less than I. Obviously area will be smaller because I plus 1 will be considered, because area of I is less than area of j, area of I plus 1 is obviously less than area of j, so I plus 1 will be considered, obviously lesser area, I plus 2 lesser area. But if I plus 3, the area of I plus 3 is greater than area of j, that means height of area of j is fully considered. It is the maximum height has been found till now, area of j. So if area of I is less than area of j, then you have to try and increase the height of a rectangle. Condition 1, try and increase the height of a rectangle, I plus plus. And if area of I is greater than area of j, you have to try and increase the height of a rectangle. Area of I is less than area of j. Area of I is greater, sorry, greater than area of j. So the entire height of area of j has not been utilized. You find something which utilizes the entire height of area of I. And in the process, whatever height comes, j, j minus 1, j minus 2, j minus 3, that will be fully occupied. That will be legally considered. If j minus 3 is greater than j minus j, if area of j minus 3 is greater than area of j, then obviously it is understandable that area of I, j minus 3 will be taken, because area of I is greater than area of j minus 3. So you will decrement j. And this thing ends when I becomes greater than j, and at the end return ans. Or I becomes equal to j. If the I becomes equal to j, if the I becomes equal to j, see, this condition is lesser, so I comes to j. Then this is a vertical. It cannot store water. It is a vertical. It can't store water. It has any. It doesn't have any weight. In this case, the weight becomes 0, and thus no water can be stored. And if I is greater than j, so there is no point in considering this, because no water can be stored. And if I is greater than j, there is no need. Which is called, I will return answer. Now let me show you the time and space complexity. A simple order of n by 2. In a worst case, this will be order of n. These all are order of 1. So basically, time complexity is O of n, and space complexity is O of 1. So let me provide you the code. So this entire notebook, as always, will be present in our website, https:// There's nothing new. Increase the number of signups, because if you do not sign up, you will not be able to see the library, the chat, the meet. You will not be able to see anything at all. The notes will be present in the library sections, resources tabs, community library. So this, okay, so before ending the video, let us run and submit it. So while it gets submit, I request all of you to help us with help us Kepler Educations with, it is completely done perfectly, it is submitted. So help Kepler Education with our targets: 150 likes, more than 500 views, 150 likes, and a lot of comments, all of those conditions. So it is submitted perfectly. So this puts an end to today's video. So thank you for watching. See you in the next video.